Hello, my name is William Driggs-Campbell, and my presentation is on types of databases, specifically relational and non-relational, or SQL databases and NoSQL databases. So why I chose to do this as my topic is because I took a database management class last year, and it was all about relational databases. We did our project in PostgreSQL, and I liked it a lot. And I've talked about it to lots of recruiters and stuff about trying to get jobs. And one of the most common questions after I mention it is whether or not I know anything about non-relational databases. And previously, I didn't. So now hopefully I can answer that better. But so just some background on relational databases. So they're generally just SQL based, and so SQL came around in like the mid 70s, and it's just the idea is that everything gets all your data is just like related together or to each other, and it organizes all data into tables, and like each table is a like an entity type, so that could be like a product, a customer, in like insurance policy. It could be anything like that. And then each row in that table is like an instance of that type. So that's like one specific customer with a unique key identifying them. And then all of the columns are attributes to that. So it could be customer with unique key ABC, first name Bob, second name Smith, yada yada. But so this the pros and cons of relational databases is it works extremely well with just structured data, and because of the way it's set up, the data in the table has built-in integrity. It's always gonna like follow the correct schema if it's in the database, and you can use foreign keys and whatnot to like link information between tables. So it's like you can have your customer key, but then you can also have the product key that they like what your customer bought, and that links it to another table, and it creates that relation. And you can query really well with relational databases, but the problems with it is that it doesn't scale horizontally well at all. And it's because of how many joins there are, and it as you get more and more data, it does get slowed down, and you need the structure in your data, the schema, in order for it to work at all. So if you don't have that structured of a schema, it's difficult, or if your schema is constantly changing, it's difficult. And also, like, you need to know the database to be able to query it. So here's just some examples. So on the left is just like an example of a relational database. So there's the book with its book ID, and then it has the author ID and the publication ID, and that links to the different tables, and then it has the Cold Fusion for Dummies, yada yada. And then here's just the common like software is used for relational databases. So for non-relational databases, it first came up as like the NoSQL was in like the 1990s, but that was sort of just a relational database that didn't use SQL. But then it came up again in like around 2008 when they started trying to create like databases to deal with this unstructured data that was needed for like the massive explosion of data that had been coming up because of the internet. So it's like a bunch of companies are now researching and using NoSQL databases like Facebook, Twitter, LinkedIn, Google. They all have NoSQL systems because it just processes unstructured data so quickly. And so yeah, non-relational data doesn't need a schema. It scales horizontally, and it uses base which is basically available, soft state, and eventually consistent for consistency. And so this is an alternative to ACID, which stands for atomicity, consistency, isolation, and durability. But so ACID is used for like relational databases, and it has like a pessimistic view on data integrity, and it forces consistency in your data at like every possible instance. Whereas base has an optimistic view. It accepts that your database is like in a state of flux, and it will change, but it will ultimately end up being right. All right. And then, so there's several categories of non-relational databases, and the most common and basic one is key value storage, and there's no need for schema. It's all opaque. It can grow super wide without needing any significant redesigns. Basically, a key value storage it's like a dictionary data structure, sort of. And then document storage, it's a subclass of key value, but it processes the data differently, and it's really good for when your schema is just constantly changing, and each document doesn't have to have the same schema, the same number of attributes or types or anything like that. And then wide column storage, this is what like Amazon's DynamoDB uses. It has tables, rows, and columns like a relational database, but everything can vary from row to row in the same table. So you can have one row with a column attribute spaghetti, and then the next one the attribute's ravioli, and you can just change it as needed. And so it's just like a two-dimensional key value store. And then a graph database is just it stores as a graph, and it uses like graph storage and graph processing, and this is really useful for when like relationships between data points matter. And it's sort of interesting. This doesn't work well in like traditional relational database systems, because they are actually sort of bad at handling relationships because of the rigid schemas. So the pros and cons of non-relational databases is they scale horizontally really well. They can do unstructured data, and they don't need a schema, and many of them are open source. But they are not as consistent. There's not as much like support for joins. Your data is not normalized. So that all comes down to like your data integrity has to be done in your code and stuff. But it's just a sort of polar opposite to relational databases. And here's some examples. So there's DynamoDB, like I mentioned. MongoDB is huge. Couchbase is pretty big. And here's just a little picture depicting the different types of just types of non-relational databases. And then how to decide which one to use. The biggest thing is just how your data works. If it's going to be, is it structured, unstructured? How much of a schema do you have? What, like, how do you want to model it? And like, how much consistency do you need? And then how much room for like growth do you need? Those are really the main, from all my research, they seem like the main questions to ask going into it. And so the future for non-relational databases and relational databases is they are trying to sort of merge the two, create hybrid systems that will just bring the best qualities of each one together, and hopefully that works out. Yeah, that's it. There's no questions because I'm just doing this in my room. But yeah, have a good day.